Hello, welcome. This is the next Edexcel S1 tutorial. This is now on a chapter called Representing Data. Okay, so in essence, what I'm going to be doing through this video is just giving a recap of stem diagrams. This is a back-to-back stem diagram behind me. Anyway, that's just, you might have done it, you probably did it at GCSE anyway, but it's just a recap because you might get a question on it. Which would be nice. And I'm going to be then talking about box plots, and then introducing a new thing called Outliers. Okay, and then I'll go into about that. And then I'm going to look at something called skewness, what we mean by it, how we can calculate it, and how adding certain values to an already known skew, how will it affect it. So if, for example, it's symmetrical and we add a few more values to this set of values without calculating it again, what would happen to the skew? Okay, so the first thing I'm going to talk about is this on the board. I'll kind of move out of the way so you can see it. Okay, so this key, you always need to show that, even though it's the most obvious thing in the world, you need to show that 2 line 3 means 23, okay? Or whatever case it might be 200, you just put whatever you want it to mean, okay? Now, this is a back-to-back stem and leaf diagram because, well, weirdly enough, we've got one stem and leaf diagram going this way and another one going that way, but they're both using, obviously, the same stem bit. But as I said, I've just probably wrote too many numbers on this. It's not really that difficult, as I said. I mean, you would never be asked to, work out something from that, apart from maybe the mode, median and mean, but then again that's just simply working out how many numbers are there and then looking at the middle one and then counting to that middle one, circling it and just showing what it is. But hopefully, as I said, I don't need to go over stem and leaf diagrams because I'm assuming they're very, very easy for you, and I just wanted to recap what a back-to-back stem leaf diagram was. Okay, so the next thing, I didn't really want to spend too long on that, to be honest, because I'm kind of assuming you already knew all of that, to be honest. And as I said, calculating the mean would just be simply adding all the numbers up, and you'd have to convert them. And you might not be given it in that form. You might have to one of the questions you could be asked is to put it in a stem and leaf diagram form, okay, but it's nothing too challenging, okay. So what I'm going to go on to now is a thing called box plots and outliers, okay. So I'm going to use that data actually because I probably have to spend a bit more time on it. So what I'm going to do now is hypothesize, sound intelligent, some bits of information, okay. So let's say that we've got, I don't know, a point system, okay, in terms of, score, I don't know, just an example, points scored in a game, okay, not a game of football, just a game, okay. So let's say that the lowest recorded value, is equal to 10. Okay, and the maximum value so this might not be so smooth because I'm just thinking of it now. Actually, should we call it, I don't know, maybe we should call it the lowest about that value 0. Let's call the maximum value, should we call it 40? Okay, call the maximum value 40. Now, what we're going to do here is I'm going to call them a median, but obviously this would be just a spread of data, so it's not the middle between 10 and 40, even though that's what the median suggests. It's the middle number, okay? So I'm just hypothesizing there might be 10 10s and 2 12s, etc, etc. So this is just an imaginary distribution, okay? So let's say the median, okay, of the set of data was 25, okay, and then let's say the lower quartile was 12, okay, and the upper quartile was 42. Oh no, shut up. Sorry, let's say the upper quartile was 34. Okay, so if basically this might be all your information from a set of data you've calculated in a question. Now that might be from group data, like we were looking at in the last video, where we used linear interpolation to find the upper quartile, lower quartile, median, etc. And you could just look for the lowest and maximum values. Okay, so now we know all that. How would we put that in a table, in a box plot? Now, what we would do naturally, say obviously you would have a proper sheet of graph paper, but for reasons, well, can't be bothered drawing a graph on there, so you can do it if you want to, but I'm doing the video, I can't be bothered, so, you know, unless you imagine one there. Anyway, I'm just going to do kind of a crude of this. So our lowest value is 10, so we'll start it, and then at the starting point I'll label that as 10, okay, and then our lower quartile is 12, so when you get to 12, you draw kind of the start of this box. So you draw a big line like that, and then you write that as that occurs at 12. And this box, and then yeah, and then you continue this box, okay, up until the upper quartile. Okay, so we say the upper quartile was 34. Okay, and then so that's your box, and then when you've got yeah, and then you continue this box all the way up to the maximum value of 40. Okay, but your median is obviously going to be inside this box. So wherever your median lies, you draw a straight line down in the box. Okay, so 25, that is your median. Okay, so that all looks fairly simple so far. Now, obviously, you'd be given graph paper, so it'd be a lot more accurate. Okay, anyway, so some of the time it will mention to do this, and some of the time it won't. But the key thing is, you always do this. You always add this on to any box plot you'd ever draw in S1, okay? Doesn't matter if it tells you to or not, you'd still add it on. And what I'm talking about adding on here is something called something called outliers. Now outliers just say, is essentially, we've got our range there and our quartiles and upper quartile, lower quartile and quartile range, obviously. And you say, does that actually fit or is that an anomaly? Because from that might look right, it might, to some people it might not. In other words, it might look like it should be, say if we knew the spread of data or something, or what type of score this was from, as I just hypothesised it was a game, you couldn't spot straight from that with true fact that there is an outlier or there is not an outlier. Now if we knew the exact relationship between these two variables or whatever they were, then we could spot, well, yes, that's an anomaly, no it's not. If we drew a graph, for example, well, we don't really know the true outliers here. So we come up with this formula. Now you don't need to know why, but basically the formula comes in two types, to work out the upper outlier, and if there is any, and if there's any lower outliers. And what we do is formula says, it gives a value, works out a value, okay, and anything to this either side of that value is considered to be an outlier. So if it's the upper outlier we're finding, okay, you will get a point, you'll get a value from using the upper outlier formula, and anything above that will be an outlier. And then if we were to look at the look for the lower outlier, we get a value for that, and anything on less than that we consider to be an outlier or an anomaly. Okay, so the two formulas you need to know: the upper outlier okay, well, what it is it's the upper quartile, UQ, plus 1.5 times the IQR. And obviously, you know the IQR is the interquartile range, which is upper quartile, take lower quartile. But hopefully I don't need to say that to you. So that's the upper outlier. And the lower outlier uses a similar thing. So as I said, the upper outlier, any value above the upper quartile plus 1.5 times the IQR is considered to be an outlier. Okay, so anything greater than that is an outlier. The lower quartile is lower quartile. Now, we're not adding on 1.5 times the IQR like we did before. Otherwise, because then we'd be, if you can imagine this was the original range, what we're doing is looking at the upper quartile, say there, and then we'd be moving the lower quartile up. We'd say, if we were adding on 1.5 times the IQR, and anything less than that was a lower outlier, then we'd be saying the lower quartile is an outlier straight away. We don't know that, okay? So we have to take, we do the lower quartile minus 1.5 times the IQR. So this just shows how far, essentially, the whiskers, this is the lines coming out of the box, we call the whiskers. Now, not the whiskers of a cat, you'd be quite mean to stretch them out. But it's just saying how far really can the whiskers stretch in comparison to how big the interquartile range is. So that's what these two are showing, okay? So we'll just do this for an example. Now, quite clearly, you know, so I just work out the IQR. So we know the interquartile range, IQR, is equal to the upper quartile minus the lower quartile. And if we relate it to this set of data, it's 34 minus 12, which is obviously 22. That's right, isn't it? 10. Yep. Yeah, sorry, just making sure that wasn't going crazy. So the interquartile range is 22. Okay, so if we apply it to the, let me do it in a different colour pen actually. So just apply all the information we've been given into the interquartile range. Sorry, the upper and lower outlier formula. Now I'm going to have a go at that as soon as I can get a different coloured pen. But if you want to have a go, pause of it now, and you can have a go at that just using all the information we've got on board. As I said, it's simply just subbing numbers into a formula. I'll pause the video now so you can have a go at it. Okay, so it's just a case of subbing the numbers in. So, I mean, all I wanted you to really do was just, you know, show the upper and lower outliers if there was any. And I'm just going to, after that, show you what you'd do if there was any. If there might be. Okay, so if there's any outliers, it's the upper quartile, which is 34, plus 1.5 times the IQR, and the IQR is 22, so, okay, so it's 34 plus 1.5 times 22, that gets you 67. So, as the maximum recorded value is 40, which is obviously less than 67, it is not an outlier. So we don't do anything else, we just leave it as it is. Okay, okay, so that's any upper outliers. The lower outliers is the lower quartile, which is 12 minus 1.5 times 22. Okay, which is obviously going to get you a minus number, okay, whatever that comes to. Okay, so 12 minus 1.5 times the IQR, which is 22, okay, which is minus 21. So the lowest value we can have is minus 21, and the maximum value is 67. And as 10 is less than 21, it is not an outlier. However, let's just hypothesize something for a second. Say if the interquartile range is now changed, okay, so let's come up with a new, box plot, okay, so you can kind of ignore all of that value actually. Okay, so let's come up with some new means, medians, etc, etc. So let's say the lowest value, let's come up with something ridiculous to make sure this works. Say the lowest value is minus 900. Okay, so this could be degrees of something, for example. The lower quartile, okay, is, let's say, 25. Let's say the median of this set of values was 50. And let's say the upper quartile was 60. No, actually, no, it's too big. Sorry, one sec, let's change it. So the lower quartile, let's say that's 45, and the upper quartile, let's say that's 55. Okay, that's better. Alright, and then let's say the maximum value, let's say that was, actually, one sec. say the maximum value was 800. Okay, so obviously you'll be looking at this thinking, them two maximum recorded values look a bit weird, to be honest. The lowest value and the highest value recorded seem very, very far away from the median. Okay, so let's just draw this as a box plot initially without doing the outlier test. Okay, so it starts at minus 900 because that's the smallest recorded value. The upper quartile somewhere right over there. Okay, and that's at 45. The median, okay, well that's 50, and the upper quartile is 55, and the maximum value is all the way over here at 800. Now there's one thing, actually no, I'll bring it up later. Okay, so let's just check if there's any upper, like we think that the minus 900 and 800 look a bit weird. They don't look like they should be a part of this results. Okay, so let's do the upper outlier test. So the upper outlier is the upper quartile, which is 55, plus 1.5 times the IQR. IQR is upper quartile, take lower quartile, so that's obviously 55 minus 45, that's 10. So, okay, that's the upper quartile. So in other words, it's 55 plus 15, because it's 55 plus 1.5 times 10, which is 70. Okay, so any value greater than 70 is an upper outlier. Do the test for the lower outliers. Okay, so it's lower quartile, which is 45 minus 1.5 times 10, in other words 35. Okay, so any value greater than 70 is an outlier, and any value less than 35 is an outlier as well. So let's just take into account what we've got here. Okay, so let's mark on this 70 and 35. Our 70 really is about here. Okay, and our 35, we'll just put it somewhere about here. And if they were the two extremes, that looks to me fairly explanatory. So it's got a difference either side, median of 5, and it looks 35 and 70. That's what you'd expect. If you saw that, you thought that'd be all right. But we had values of 800 and 900. They were recorded. This could have been for a test, for example, a science experiment, for example. Okay, so as we said, any value bigger than 70 must be an outlier. So you can imagine crossing this off. We also said any value less than 35 was a lower outlier, so we can cross all these values off as well. But how do we actually draw that? Because that doesn't look too mathematically correct to just scribble it out, and that's not. What you would do is obviously you wouldn't mark on these massive lines here. You just say that's 70, that's 35. Okay, and then what you would do, okay, you draw it up, you draw the lines up to 70, but we had actually recorded values of 800 and minus 900, so we can't just get rid of them altogether. Because we still recorded them, we still have to put them down, but we can't draw a line to them. So what we do instead is just put an X at them values, because we say we got them values, but we know they're an outlier. Okay, so that would be your new style of graph. Okay, so as I said, you can come up with any values of the upper, lower, median, upper quartiles. Just test yourself by coming up with random values and see if they actually work. Okay. So as I said, you can just create your own questions on that. If you have any more, please let me know. I'll go through some for you. Okay. So hopefully that makes some kind of sense. It's not too difficult, that really. I guess it's just a case of working it out. But there's one more thing on Boxplots they might ask you, and this does link, I think, quite nicely to. I'm not sure if it links to another topic. I'll have to check. So let's draw that again. Just this. Okay. All I'm going to focus on is that boxplot we ended up drawing. Okay. So let's say the lowest value was 35. So I'll just draw this back on a sec. My crap drawing. Okay, so that's medium was 50, quartile was 55. Okay, so if you were to just look at that, okay, and say, is that positively skewed, is it negatively skewed, or is it symmetrical? First of all, you need to say, well, what the hell does all that mean? Well, you obviously know what symmetrical means. It's the same on one side as it is the other. But what we're saying are we saying from 50 to 70, that's the same as 50 to 35? Well, clearly it isn't. What we're looking at here is the distributions between the upper quartile and the median and the lower quartile and the median. If the distance between the upper quartile and the median is the same as the distance between the lower quartile and the median, in other words, the change in numbers between the lower quartile and the median is the same as the change in numbers from the median to the upper quartile, then we say it's symmetrical. But if one of them are bigger than the other, then it's obviously not symmetrical at all. So what do we dictate as being positively skewed and negatively skewed? Okay? Alright, so as I said, it's going to be skewed if there is a bigger distance between the upper quartile, there's going to be a bigger distance between the upper quartile and the lower and the median, or if there is sorry, I'm just double checking something. Sorry, one second, just double check something. Sorry about that. Just because I was looking, and there are a couple of ways you can dictate the skewness of something. Okay, so the easiest one to do is looking at the distribution between the upper quartile and the median and lower quartile and the median, as I said, and it's positively skewed if the upper quartile take the median is greater than the median take the lower quartile. Okay, so that is a positive skew. Okay, and obviously therefore the opposite occurs if it is a negative skew. Okay, so in other words then, if the upper quartile take the median is less than the median take the lower quartile, then it is a negative skew. Okay, so they're the two differences. Now there is another version of this, okay, which also applies, maybe not so much to Boxplot, okay. It's if the 3 times the mean take the median over the standard deviation. And if you, just to recap what the standard deviation was, it's a square root of the variance, and we said the variance was the sum of x squared over n, take x bar all squared. In other words, the sum of x squared over n minus the sum of x over n all squared. Okay, so that is the variance, and obviously therefore the square root of that is the standard deviation, and x bar is the mean, and you can just work out the median, which in this case would be 50. Okay, now I can't work out that for this set of data because I've just come up with values for the mean, so I've just come up with values for the lowest value, the upper quartile, lower quartile, median, and the highest value. I've just come up with them. I don't actually know, weirdly enough, the individual values of how they're spread out, but if you did, you could just sum them into that formula as well. But if you were asked a box plot and you were asked to ask the skewness of the distribution, then you would always use this idea over here. If the distance between the upper quartile and the median is greater than the distance between the median and the lower quartile, then it is positively skewed. Okay, so hopefully that makes a bit of sense. And as I said, that's just a recap on variance and standard deviation. Okay, which I think I did mention in the last video as well. Sorry, I don't know if I've edited it out, but I did think I had finished and I hadn't. I've got this, I'm going to include this as well. So what I've on board obviously is a histogram. Now the first thing that you might be asking is, what the hell are these dotted lines? Well, that's just to show you the height of each bar. Okay, so the red one, the one goes from a class width of 40 to 45. That's got a frequency density of 20. The one that goes from 50 to 60 has got a frequency density 15. The one that goes from 15 to 20 and the one that goes from 20 to 40 has got a frequency density of 10, and the one that goes from 45 to 50 has got a frequency density of 5. Okay, so all very nice and easy to understand. Okay, so the first thing that you need to be able to realise is, what the hell is frequency density? Well, frequency density, the equation for it is just frequency over class width. So therefore, if you wanted to work out the frequency of any of these bars, okay, you wanted to know how many people were in it, you just do the frequency density times the class width. In other words, the height times the length, okay? Because that's just a rearrangement of the equation. That frequency density is frequency over class width, okay? So a very, very easy topic there. Okay, so that's a question you could be asked. Now, apart from drawing the bars, okay, and them giving you a group of information, okay, saying, you know, group data, they will ask you to calculate the standard deviation, the variance, and then they might actually draw a histogram on it. However, that's very easy, simply just drawing one histogram from another, from a set of data. However, the more complicated thing, and the thing they're more likely to ask you on the exam is something like this. So let's say, so I'm going to go. Just trying to word this. They might say, yeah, they might say, God, this is. I was thinking, I'm wondering if I can explain it from this diagram. I'll go ahead. Okay, so they say, let's say the frequency, let's take the easiest group to do. So let's say the 0 to 15 group, say this is in terms of how many they scored, the class width, okay? Say, obviously this has got a width of 15, okay, and a height of 15 as well. Say they say, this class, the 0 to 15 class, has got a frequency density of 15, and it has a height of 10 centimetres, okay? So therefore, straight away, we know that 10 centimetres in height is equal to 15 frequency densities. If that makes sense. So that might be the line. They might say the class from 0 to 15 has a frequency density of 15 and a height of 10 centimetres. And they might use this diagram and say, therefore, work out the height of the 40 to 45 class. Okay, so the tallest red one, that we'll call that class B, for example. Class B, the 40 to 45 class. Using the information we've been given, how high should we draw it? Now, you can't say 20 because that's the frequency density. That's not in centimetres. Okay, we have to use this ratio that 10 centimetres equals 15 frequency densities high. So it depends which way round you want to go from it, or which information you've been given. So either you want to know how tall one frequency density is, or how many frequency densities are in 1 centimetre. Whichever way round you want it, you can convert it that way. But it all depends on what information you've been given. So what I mean by that, okay, is if you know the frequency density, but you want to know how high it is, well then you need to know how many centimetres are in 1 frequency density. But if you know how high something is and you want to work out how many frequency densities are in it, then you need to do it the other way around. Okay? So in this case, we know the frequency density. And you could work out the frequency. You could do that, but it's pointless. Okay? But as I said, you might have to work out the frequency density. You might not have been given all this information. You might have had to draw the histogram first. Okay? So anyway, we want to work out how high this class 40 to 45 is. Well, we know it's 20 frequency densities high. So we need to know how high is 20 frequency densities. So to do that, we first need to work out how high is 1 frequency density. So what we need to do is use this ratio that 10 centimetres is equal to 15 frequency densities, if you can think of it like that. So therefore, how high is one frequency density? Well, we need to divide both sides by 15. So therefore, we get 10 over 15 in centimetres is equal to 1 frequency density, because we divide both sides by 15. Okay, so obviously that would get you 2/3, okay, because you could cancel it down to 2/3. So 10 over 15, sorry, is 2/3, or 0.6667 centimetres, okay? So we know that's how tall one frequency density is. Now this might not come out to be a nice number because I've just come up with this. So generally in the exam it will be quite a nice rounded number. Anyway, so we need to know how high 20 of those are. So we times both sides by 20 because we want 20 frequency densities. Okay? So you times 10 over 15 by 20, get 40 over 3, or 13.3 centimetres. And that is equal to 20 frequency densities. So that's how tall Class B is. Okay? So basically, it's all about conversion and working out how tall is one frequency density, or how tall is 1 centimetre in terms of how many frequency densities can you fit in it. Okay? So as I said, that was just a little bit on the side. I will be doing, I think I have done some S1 papers already that are on my channel, and I'll be adding to them as we go through the rest of the year. Okay, so not much left of it at this point. Okay, so there are quite a lot of questions that are very similar to that in the exam, and for histograms that's kind of the hardest type of histogram question you might be asked. Okay, so thanks for watching, hopefully it's been helpful, and we'll see you in the next video.